we really want to today kind of talk about why is metadata important, what is it, and yeah, those are kind of the two main things we're focusing on. And so we're going to do this using a sort of a real life kind of problem solving example that you might find yourself in. This example is made up. It's really just for seminar purposes. So I don't know if this is sort of the gold standard or whether this is a problem that would actually be solved in real life, but we're going to use it sort of to kind of help explain metadata and why it's important today. So some of you may have heard the term or heard the phrase data-driven decisions. It's kind of one that is becoming more and more popular, and you might hear your managers talk about, or people in higher up positions in your organization, about something that we want to be doing more of. But what exactly is data-driven decisions? So as I said, we'll use kind of an example. So imagine that you and your team are in charge of improving healthcare access across Scotland. So you want to make sure that everyone is in at least 30 minutes driving or walking distance of a GP and a pharmacy. So how would you go about kind of figuring out where are the physical gaps where you might propose new GP locations or pharmacy locations? So you and your team are trying to figure out, how do we go about solving this? And the first question you might answer is, what information do you need to be able to answer that question? So you're going to need your current GP locations. You're going to need your current pharmacy locations. You're going to need to be able to understand what is the capacity of each GP in that area. The same goes again for the pharmacy as well as how many medicines they can hold, or how many medicines have to be delivered to that pharmacy based on the population in the area. And that means that you need to understand sort of the rural-urban spread, who lives where, and then you're going to need some routing information. Routing information will require you to have a whole range of other information. And there might be other bits and pieces as well, but this is enough to kind of set us off. And all of this information is what we call data. And so the next question, after you've kind of identified what you're going to need to kind of solve your problem, you're going to have to ask the question, well, how do I find this data? Many of us are probably just going to go on Google or another well-known search engine to try and find this data. And what you're going to want to try and find out is who has this data, so what organizations own it and hold it. Is it free? And if it's free, under what license are you allowed to use it? Can you actually access and download it? Again, is there a license under which you can access and download it? Is there national coverage of the data? So, have you got the same information available for all local authorities in Scotland? Then, has it been kept up to date? What software are you going to need to be able to download or view and analyze this data? What format or what data type does the data come in? And all of this information is actually what we call metadata. So those of you that will be kind of very familiar with metadata will be able to immediately recognize this. And those of you that are maybe a bit or are not that familiar with metadata, but do kind of work with information or data, can maybe begin to realize that some of that information that you need to know sort of every day is that all important metadata that kind of we keep getting pushed to create. So there are different types of metadata that each of these fall under, and all of that, as there's also a lot of other information that kind of falls under metadata, which we'll look at as well, but each of these kind of fall into different categories. Again, there's also several different ways that you can categorize metadata. This here is one that we at the Data Standards team have chosen because we find it quite very clear. So you've got descriptive metadata, and this metadata is really important, particularly for being able to help you find data or help search engines find your data, and includes things like your title, your kind of the abstracts or the description of the meta or of the data set, or it includes kind of keywords. So in our case, that might be GP, healthcare. It also includes information or the what's called a persistent identifier, or the persistent and unique identifier. And that's really important, particularly if you want to link the data to someone else, or kind of let them find the exact data set that you're talking about. The citation metadata is similar to the descriptive metadata, and it's kind of all the information you'd need to be able to cite the data in any sort of analysis work you do. So it'll include extra information like the publication date or year, the publishers, all that sort of stuff. And then you've got the provenance metadata, and the provenance metadata is all the kind of information around sort of where did it come from, who collected it, how was the data manipulated, was it updated, and that kind of metadata helps the user be able to understand whether that data is correct, is the right data for them to be using for their problem, or also, you know, whether anything that's been done to the data affects the way that they need to analyze it themselves. The technical metadata is sort of the information that either allows for machines to understand how to read the data, or the way or for us as humans to be able to understand what sort of software and kind of technical specifications we might need to analyze the metadata. So that's things like what form does it come in, like what data format does it come in? Is it CSV? Is it JSON? What software are we using to analyze it? If it's a database you're trying to access it, you know, what is the configuration? So how can you get into the database? All of that kind of information. And then you've got the rights and access metadata, and this kind of helps the user understand that if your data is open, under what license are they allowed to use it? And if your data is not open, then, you know, are there ways that the user can access that data, whether that be through a subscription service, if it's commercially sensitive information, or if it's, you know, if the data regards vulnerable individuals, can you access that data through like the National Safe Haven or another route? And this kind of the rights and access metadata is always important, but I would almost argue that it's especially important when your data is not open, because it kind of can clearly pinpoint to the user why it isn't open and under what circumstances they can, or what process they can use to be able to access the data. And that kind of saves a lot of time through the whole process of, you know, finding and accessing and using the data. And then finally, the preservation metadata really builds on the three beforehand. So the provenance, the technical, and the rights and access metadata, and that's sort of about what is the life cycle of the metadata? Where has it been? Has it been moved to different locations? If the data is no longer available online, you know, where was its previous location, or what location has it moved to? And that kind of information that helps the user be able to make use of the data when it comes to it. And all this is well and good to kind of explain, but it's always easier to look at it from an actual example. So this here is a screenshot of the GP location information that's on spatialdata.gov.scot. And I'm just going to pull that in so we can have a better look. So yeah, so this here again, going back to the example that, you know, the problem solving example we're using for the seminar, I just went on Google and typed in GP locations in Scotland. And this was one of the first kind of searches or results that came up. And you can see when you click on it, we've got a description of the data set here. We've got the links where you can download it, as well as to be able to download it in different formats. We know the spatial extent here. We know when it was last updated. We know who published it. We know how new the metadata is. And down here, we've got all the technical information, you know, what what form it comes in. For those of you that geospatial will understand vector, those of you that don't worry about it. And all of this information here is in quite a human readable, easy to understand format. If you click on this download metadata here, we get an XML file here. Now, for those of you that aren't familiar with XML, this might look a little bit overwhelming, but don't worry about it. It's basically just all the same information that we've just seen here in a kind of very easily human readable format, in a way that your computer or machine can digest it, look for specific information to be able to see, for example, is this data set relevant, and do I need to return it in the search that you put into the search engine. And when you look into it, you can begin to see some of the information that you saw beforehand. So here's the coordinate system that the data set uses. Here, that's the title of it, when it was last updated, I believe, the description of it, of the data set here. Right. And why is all of this important? So we spoke a little bit about how metadata can help you find data more easily, particularly on search engines, because the search engine is able to kind of pull out you know, the keywords or the title or some of that descriptive metadata, and kind of return the most relevant searches or results and data sets to your search. But it's also very important for being accessible, interoperable, and reusable. And this kind of these four components come together very nicely in an acronym called FAIR. Some of you maybe familiar with the term FAIR, but for those of you that are new to that, FAIR is sort of an acronym that's been used relatively extensively in academia to help sort of the better sharing of data and reuse of data to enable more timely and good quality research. And it's been adopted by the EU to also sort of foster research into kind of, I think it's called the open science cloud, sort of the future of open science and more research in kind of an open data sharing environment. And Scottish Government, or the Data Standards Scheme at Scottish Government, are also adopting it now to sort of help explain why it is important to implement good data standards, including sort of all the standards around metadata. And so we've been over findable already, so we'll kind of just move on. Accessible, we spoke about a fair bit as well, that how the rights and access metadata help kind of make your data accessible, or at least allow the user to understand how they can access it and what process they need to go through. Interoperable is sort of, it's all about making sure that your data can work together with other data. And this topic is quite wide ranging, but one of the ways that you can kind of help make your data interoperable with other data sets is by using common metadata schemas. For those of you that are new to metadata schemas, you can think of it sort of as like an instruction manual that tells you how to fill out the metadata. So it gives you the variables that you should include, as well as what values should go in there. So, you know, if you've got any length constraints, or in some cases, you'll have what's called metadata vocabularies, which is sort of like a list of possible entries you can put into the metadata under specific variables. And yeah, as an example, I've put three very common ones here: Gemini, DCAT, and Dublin Core. And then finally, the whole point of FAIR, of data sharing, is sort of to make your data reusable. And all of the technical provenance and preservation metadata kind of helps you be able to do that. Amongst this metadata falls, for example, you know, helps you interpret the variables correctly. So it has information like what are the units of measurements, or how, you know, if it's numerical data, has it been kind of updated or changed in any way? What are the meanings of the different variables? How can you, or like what software can you use to to be able to analyze it. And all of this different kind of information helps your data be used in the way that it should be intended to be used and is correctly interpreted as well. Those are not the only benefits of metadata. There are other benefits that kind of fall out with FAIR. So firstly, it's kind of a great way to keep track of institutional knowledge. So yeah, you know, when staff members move on or get promoted to other teams or retire, sometimes their knowledge can kind of leave with them, particularly if they're particularly knowledgeable about one specific data set, you know, and if you've recorded some of their knowledge within the metadata, then that can stay within the team. It can also help build your organization as a trusted data source for other communities or researchers to use their data. And then ultimately, you know, the biggest reason why we want to create good metadata is to save time and resources, and that'll be the case both for internally for your organization, but also externally for people trying to find your data and use it. And it increases the sort of auditability and the reproducibility in the analytical processes of your data sets. And that really kind of comes to the end of today's presentation on metadata.